Hello everyone, good evening. In last class, we discussed why we come up with OSI model and what exactly OSI model is. Like we discussed brief introduction about OSI model. And as you all know, we have 7 layers in OSI model. So today we are going to focus on layers. Today we will try to understand function, working, everything at each layer of OSI model. It will, you know, be beneficial for network troubleshooting. Like if you are already network engineer, you are working in industry, or you are planning to become network engineer, right? So when you will work in the industry, you need to troubleshoot the network, and almost all troubleshooting is based on OSI layers. Getting my point? So understanding OSI layers is very important topic of CCNA. And in CCNA exam also you will see there are almost 5 to 6 questions from OSI model layers. Okay, so Cisco is also going to ask you some questions from layers. Okay, so let me first write the name of all layers here. Like we have 7 layer, and seventh one is application layer. Application layer. Sixth one is presentation layer. Fifth one is session layer. Fourth one is transport layer. Third one is network layer. Second one is data link layer. And first one is physical layer. Physical layer. So we have these 7 layers in OSI model. You know, at each layer, in OSI model, some task is going to be happen, right? As you know, OSI model is what? OSI model is a process which tell us how data out from a computer and how data enter in a computer. Getting my point? This is OSI model actually. How your data is going to out. That means what task computer is going to perform before transmitting the data from the link. Getting my point? And link is nothing but physical layer. Link is physical layer. So before transmitting the data from physical layer from the port, computers are going to perform some task on these all layer. Okay, like application layer is responsible to provide user interface. User interface. Right now, I am teaching you in Paint software. Paint is what? One interface for me. Through this interface, I can teach you. I can write something here. I can draw something here. Getting my point? Like if I want to access Facebook server, so what I need to do? Let's say I want to access WhatsApp. So here you can see there are some application running on my browser. So browser is what? One kind of interface. Like if I want to access Facebook or Google, so what I will do, I will type google.com in the browser. So this browser is acting as interface between me and actual software. Actual software is Google, actual server of Google. We are trying to hit Google server. We want to send something on Google server. So here, if I will hit enter, you can see some protocols is also working like HTTPS. So this Chrome browser is one application, not application, interface for me, between me and actual application. And application layer is responsible to provide user interface, right? So this Chrome is user interface, like application layer, like your UC browser is Mozilla Fire is. These are what? Application layer. Fine. So application layer is responsible to provide user interface between user actual application. Here also in my note, you can see application layer act as an interface between user and actual application. So if I am sending something, let's say some file to my friend, right? My friend is, let's say 100 kilometers far from me, and I am going to send something through WhatsApp. right? So let's say I want to send this file through WhatsApp. So WhatsApp is what? One interface. Through WhatsApp, I can send that file to my friend. So WhatsApp is acting as a interface between me, user, and the actual application. Getting my point? So that is application layer. This layer tell us an application is internet based or not. Application layer is responsible to identify your request is internet based or not. Let's say two computers are directly connected with each other through one cable. Let's say here I have one computer and here I have one computer. Both are directly with each other. Let's say here I have one book, CCNA book. I want to send this CCNA book from this computer to this computer. Let's say this computer is computer A, this is computer B. If I want to send this file from computer A to computer B, internet is required or not? So answer is no, internet is not required here. Internet is not required here. So who will tell to this machine that if you want to send this file, then internet is not required? If you are typing www.google.com in the browser, then you are hitting actual app, server of Google. So who is telling to devices? Application layer, that your request is internet based or not. If I want to send file between two computer, internet is not required. Application layer is responsible for it to identify. We can send file through FTP. So for that, internet is not required because both are connected and both will have one IP address. Let's say this machine have IP address 10.1.1.1 and this machine have IP address 10.1.1.1.2. Now both can communicate with each other. We can share some data. We can exchange some data without internet. But this machine cannot access Google now because this machine is not connected with internet. Fine. So let's say here we have one router and this router is connected with ISP. Now this machine can access internet also here, Google server. Google. So now this machine can access Google server. So this time when this machine will try to access Google server, application layer will inform to this machine that this request is internet based because we are typing www.google.com in the browser. Getting my point? And these are functions of application layer. This is a brief introduction about application layer. Application layer acts as an interface between user and actual application. This layer tells us application is internet based or not. There are various services like web service. There are various services like web service, like file service, like remote access service, time service, mail service, etc. These are what services like we can access web page of Google server or of Facebook, yahoo.com to any application. What we can do, we can access web page with the help of protocol. So this layer, application layer, provide these services like web service. As I told you, it is an interface. So if there is no interface, we cannot interact with the application. If I don't have any interface to interact with Google, then I cannot access Google server, right? So like web services, we have web services, we have file services, like we can transfer some file from one device to another device. We have remote access service. If we have a device, at remote location, and let's say we want to modify the configuration of that device. Physically, I am not available at device. I am far away from my device. Then also I can troubleshoot my device. I can change the configuration of my device with the help of remote access service. So this is service. We have some protocol for it, like we have Telnet, we have SSH, we have these two protocol for it. So application layer provide this service also, like remote access service. If I will talk about web page access, if you want to access web page, then you have two protocol. One is HTTP and another one is HTTPS. HTTP stands for Hypertext Transfer Protocol. HTTPS stands for Hypertext Transfer Protocol Secure. Difference between both is simple word S. This S is secure. Means HTTPS is secure and HTTP is not secure. Your data travel on the internet in the plain text in case of HTTP. Your data will travel on the internet in the encrypted format in case of HTTPS. So if you will see which protocols here I am using, so you can see I'm using, I have typed www.google.com and I am using which protocol here, HTTPS, because no one is using HTTP. If security is not your concern, then you can use HTTP also, but HTTPS is more secure. So we have two protocol to access web page. Doesn't matter which type of web page you want to access. To access any web page, we have only two protocol. One is HTTP, one is HTTPS. Either I will use HTTP or I will use HTTPS. Now let me give you one example here of application layer. Here, let's say this is my computer and my computer is connected with broadband router and this router is connected with internet, let's say. And here in the browser, I am typing this www.google.com. If I will type www.google.com in my browser and I will hit enter, first this machine will generate one HTTPS request message. It will generate one HTTPS request message. This machine will generate HTTPS request message. That means which protocols we are using here? HTTPS, not HTTP. And after that, this is responsibility of application layer. Application layer will generate this HTTP request at application layer, and then it will hand over this request message to lower layer, that is presentation layer, right? If I want to access some devices, so I will run this command here, telnet. Let's say, let me design the scenario first. This switch is connected with, let's say, one router here, and on this router, telnet service is enabled. Telnet is application layer protocol, which is used to access networking devices remotely. As I told you, remote access service. Application layer is providing remote access service, and telnet is one of the protocol which provide remote access service. So here on this router, I have enabled telnet, and let's say IP address of this router is 10.1.1.1. This machine IP address is 10.1.1. Let's say 2. So in the command prompt of this computer, if I will type telnet and then IP address of router 10.1.1.1, what application layer will do at this machine? This time application layer will generate one telnet request. Telnet request. If I will type www.google.com in the browser, application layer will generate HTTP request. In the command prompt, if I will type telnet and IP address of router, then this router will generate telnet request. And in both cases, application layer will hand over it to lower layer, that is presentation layer. That is presentation layer. For any purpose, doesn't matter what activity you are going to perform on this computer, right? Application layer responsibilities generate if you are using application layer protocol. See, again, we have one concept. Some protocols work at application layer, some protocols work at other layers like transport layer, network layer, data link layer, right? So which protocols work at which layer? See, like HTTPS. HTTPS generate their messages. This is HTTP request is a type of message of HTTP protocol. It is the kind of message in HTTP. Okay. So the HTTP request. So application layer is generating this HTTP request, and application layer will hand over it to lower layer, to presentation layer. This request is one kind of HTTP message. So HTTP protocols generate their message at which layer? If someone will ask you, tell me, message of HTTP generates at which layer? So simple answer is at application layer. Here we are able to see at application layer, machine will generate HTTP request message. So HTTP protocols generate their message at application layer. That means it is an application layer protocol. It is an application layer protocol. In networking, we have one protocol called OSPF. So OSPF protocol work at network layer in OSI model, network layer. So all messages of OSPF protocol will be generated at network layer. Message of OSPF protocol cannot reach to transport layer or session layer, presentation layer, or application layer, because their message will generate at layer, because the protocol works at network layer. So always keep in mind, network layer will always hand over data to data link layer, and data link layer will hand over to physical layer. Application layer will hand over data to presentation layer, presentation to session, session to transport, transport to network, network to data link layer, and data link layer to physical layer. Okay, so these are application layer protocol like telnet, because telnet generate their messages at application layer. HTTP generate their messages at application layer. Like this, we have many more protocols. Let me show you all protocols which works at application layer. See, HTTP. First of all, we have these services on application layer. Now we can access these services with the help of some protocol like HTTP, TFTP. TFTP is used to transfer file. HTTPS, Telnet, SSH, SMTP, FTP, DNS, etc. And who designed this protocol? Application developer designed this protocol. Application developer designed this protocol. As a network engineer, you don't need to learn, application layer, upper three layer. Upper three layer is not important for you. Let me show you here. Application, presentation, and session. These three layers are not important for you, because app developer works on this layer, like software engineer, software tester, software developer. Those guys work on these three layers. As a network engineer, you will work on these four layers, lower four layers. Okay. As a network engineer, you will work on these lower four layers. On upper three layers, software engineer work. Okay. So application layer is responsible to provide user interface. We have some protocol at application layer like HTTP, HTTPS, DNS, DHCP. Then we have FTP, then TFTP, then NTP, etc. So these are protocols. Works at application layer. Works at application layer. So HTTP is used to access web page. HTTPS is also used to access web page. DNS is used to resolve domain name into IP address. DHCP is used to provide IP addresses to the machine dynamically, means automatically. FTP and TFTP is used to transfer file, and NTP is used for network time protocol for the time synchronization of device. And we have many more protocols like this, like you can mention here Telnet or SSH. So there are many more protocol at application layer. Okay, so for now we discussed that application layer is responsible to provide user interface between software and actual user. We have some protocols at application layer. Actually, application layer provides some services like web services, file transfer services, remote access services, automatic IP address configuration services, right? And we can access these services with the help of some protocols, and these are the protocols. Now, presentation layer. Guys, presentation layer is responsible to encrypt or decrypt the data. See, with the name it is clear, like presentation, presenting something, right? So presentation layer is responsible to present the data in actual format. Sometime, let's say I have one scenario. I need to send one file to my friend, right? And file size is 1 GB, let's say. And WhatsApp is not allowing me to send 1 GB file, through WhatsApp. Through WhatsApp, you can't send 1 GB file. So what I can do? in the market, in the Play Store, there are many software available which can compress your data, which can compress your data. And after, data transferring means when your friend will receive the data, then they can decrypt it. They can, again, you can decompress it. Sorry, not decrypt, decompress it in actual size. So application layer is responsible for this type of work, like encrypting the data. If I will send the data in plain text, anyone can capture the link and read my data. So I need to encrypt the data before transmitting from the link. So presentation layer is responsible to encrypt and decrypt the data also. Automatically, when your computer will, whenever application layer will hand over any data to presentation layer will perform this work, like compressing data, like decompressing the data, encrypting the data, decrypting the data. So presentation layer is responsible for this. Let me write here, encryption. It is responsible for encryption, decryption, compression, and decompression, right? And after that, presentation layer will hand over the data to session layer. Now session layer will do one thing. Session layer will create one session. It will write on the time. Like sometime you might have observed, when you are accessing some website, you are getting this error, request timeout. So actually session layer is providing this information. Whenever your machine will send any request to any other device, session layer will write on the request time, and it will expect reply within a predefined interval of time. And that interval defined of time depends on application. It can vary application to application. Get my point? Let's say I am trying to access web page of Google server. So in the browser, I will type www.google.com. And let's say timeout of this session is 2 seconds. So within 2 seconds, if I will not receive the reply message, because first my computer will send HTTP request, then server will send HTTP reply message, right? So if my device will not receive reply within 2 seconds, then session layer will give you one error on the screen, that application request timeout, or session timeout. It can be anything. So session layer create session, it maintain session, and then hand over data to transport layer. Now this is the actual layer for you, transport layer. Guys, transport layer, in very simple word, if I will try to explain transport layer, so I can say transport layer is responsible to provide port number to the data. First of all, let me give you one example here. Let me tell you something. Let's say here I have two computers directly connected with each other. Computer A is connected with computer B. This is MAC address of computer A. MAC address of computer A is A. Computer B is B. IP address of computer is 10.1.1.1. IP address of this machine is, let's say, 10.1.1.2. Fine. Okay. On this computer, let's say I am hosting one application. Or what we can do, let's say, let me do one thing. Let me design the diagram again. This is computer, and let's say this is server. Computer is connected with server. This is server, this is PC. PC MAC address is A, server MAC address is B. PC IP address is 10.1.1.1, and the server IP address is 10.1.1.2. Here we are running this application www.CDP network.com. Here we are hosting this application www.cdpnetwork.com on this server. And on this computer, if I will type www.google.com, google.com, sorry, cdpnetwork.com in the browser. So what this machine will do, this machine will generate one HTTP request message, as I told you, HTTPS request message, and application layer will hand over it to presentation layer. Presentation layer will do what? It will encrypt the data, it will compress the data, and then it will hand over to session layer. Session layer will create the session and it will start maintaining that session, and then it will hand over to lower layer. Now what transport layer will do with this data? Transport layer will add source port and destination port number with this actual data. Source port number will be random port number 1025. Soon we are going to discuss port number also. Okay. And destination port number will be well-known port number of HTTP protocol. Each protocols have one well-known port number assigned for transport layer. For transport layer, each protocols have one port number. How we can identify the services at transport layer? With the help of port number. Like how server will came to know that this request message is coming for HTTP. Because HTTP service is running. So port number is required here. Port number of HTTPS is 443. Okay, 443. And then transport layer will hand over it to lower layer, means network layer. Network layer will provide source IP and destination IP. Network layer is responsible to provide IP addresses, source IP and destination IP. Transport layer is responsible to provide port number. Network layer is responsible to provide IP addresses, and data link layer is responsible to provide MAC address. Data link layer is responsible to provide MAC address. So network layer will add source IP, that is 10.1.1.1, destination IP 10.1.1.2, and then network layer will hand over to lower layer, means data link layer. Data link layer will add source MAC is A, and destination MAC is B, right? And then data link layer will hand over it to physical layer, and physical layer will forward it, transmit from the link, and this is how server will receive this HTTP request message. At which layer the server will receive this message? At physical layer. Physical layer will hand over the data to data link layer, to this layer, data link layer. Now what data link layer will do? Data link layer protocol will check destination MAC address. If destination MAC address is the MAC address of same device, then only it will accept the packet, otherwise it will discard the data. Otherwise it will discard the data here, right? So this time destination MAC is B, right? MAC address of this server. So it will accept it. It will check some more information here. We will discuss about that information also in upcoming day. And after that, data link layer will came to know that I need to hand over, accept this layer information. First data link layer will check destination MAC address. After that, it will compare destination MAC address and their own MAC address. If both will match, then it will remove this header. It will remove lower header and it will hand over rest data to network layer. Now what network layer will do? In the same way, network layer will check destination IP address. The destination IP address is matching or not. Destination IP address which is coming in the packet and my IP address, both is 10.1.1.2, both is same. So network layer will also remove this information, this header, and it will hand over rest information to transport layer. What transport layer will do? Transport layer will check destination port number. Destination port number is 443. Transport layer will came to know that, okay, this is a request message for HTTP. Yes, HTTP service is running on me or not. If HTTP service is not running, then server will discard it. If HTTPS service is running, then server will hand over actual HTTP. It will also, the transport layer will remove this header and it will hand over this actual information to HTTP protocol at application layer. And then HTTP protocol will generate reply message. This is how OSI model is going to work between two computers. Like I have mentioned same thing in notes also. Let me show you. Presentation layer, you can see at this layer data is presented in a standard format. The data can encrypted, decrypted, compression and decompression at this layer. Like you can see, if data is 1 2 3, so we can encrypt this data into ABC, and again we can decrypt ABC into 1 2 3. Then session layer. So this layer create, maintain and terminate session. This is done with the help of session ID, and you don't need to learn these three layers as a network engineer. Just you need to keep protocol number of application layer protocol in mind. Protocol number, port number of application layer protocol. What is port number of HTTP? What is port number of telnet? This is important for you. After that, my next topic is port number. Before discussing transport layer, I should discuss this port number. So what is port number? Port number is 16 bits. It is 16 bits value represented in decimal. So range can be 0 to 65535 because it is 16 bit value. 16 bit value. So range can be 0 to 2 to the power 16. So 2 to the power 16 is 65536. So range will be 0 to 65535. So this is range of port number. What is port number? Port number is unique ID of protocol in computer networking. Each protocol, each you can say application layer protocols, like we have discussed some protocols, HTTP, FTP and many more. So those all protocols will have one unique ID, and that ID is called protocol. That ID is called protocol number, port number, not protocol, port number. Fine. So if I will talk about the port number of some protocols, so here you can see file transfer protocol. We have one protocol, file transfer protocol, to transfer file from one computer to another computer. So we have two port number for this protocol FTP. One is 20 and one is 20 and 21. And this protocol uses TCP at transport layer. See, transport layer, at transport layer, we have two important protocol. One is TCP and another one is UDP. We are going to understand the difference between TCP and UDP also, but at transport layer, each protocols will use one protocol, these two, from these two. So FTP protocol use TCP at transport layer. Secure cell SSH protocol, which is used to access networking devices remotely. We have port number what? 22, and it uses both TCP and UDP at transport layer. Then telnet protocol uses port number 23. So you can see all protocol have one port number at transport layer. SMTP port number 25 uses TCP at transport layer. DHCP uses port number 67 and 68, UDP at transport layer. POP3 uses port number 110 and TCP at transport layer. NDP uses port number 123 and UDP at transport layer. HTTP uses port number T and TCP transport layer. 43 uses HTTPS and TCP at transport layer, like this. As a network engineer, you have to keep these things in mind. Like what is port number of, like, because interviewer can also ask you this type of question, what is the port number of telnet? Fine. So let me move. There are two types of port number. One is well-known port number and another one is unknown port number. Well-known port number are those port number which are already assigned to protocol, like HTTP have one unique port number. That means one port number is already assigned for HTTP or HTTPS or FTP, TFTP, NTP, POP3, right? For these protocols, we have already defined port number. So well-known port number are those port number which are already defined to services, to protocol, and unknown port number are free. Unknown port number are free. Like here I have one computer and this is one router. I want to access this router remotely. So this machine need what? Source port, destination port. So destination port is telnet, because we are going to use telnet protocol to access this device remotely. So protocol is telnet. So destination port is 100% sure, telnet 23. But what will be the source port? Source port will be the random port number. This machine can pick any port number from this range as a source port number. As a source port number, they can pick any number from this range. I will show you these things practically also. Then you can see transport layer. This layer provide reliable and unreliable delivery. Transport layer is responsible to provide reliable and unreliable delivery. Means transport layer will decide that your communication is going to be acknowledgement based or not. Let's say I have computer A and computer B. I want to send something from computer A to computer B, right? And I don't want acknowledgement of this data. Let's say I have sent one data from computer A to computer B and I don't want acknowledgement of this data. So this is what? Unreliable communication. This is unreliable delivery. But if I am sending the data and I am expecting acknowledgement, means after receiving this data, when computer B will receive the data, computer B will generate one reply acknowledgement message, that yes, I have received your data. So this is what? Reliable communication. So transport layer is going to decide that communication is going to be happen is reliable or unreliable. Communication is going to be reliable or unreliable. Fine. Transport layer is also responsible for error correction before transmitting. If there is some error in the data, transport layer is responsible to correct it, right? Then, as I told you, two major protocol works at this layer. Two protocols are work at this layer, that is TCP and UDP. TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. User Datagram Protocol. As I told you, transport layer will decide communication is reliable or unreliable, right? So for reliable communication, we will use TCP protocol. For unreliable communication, we will use UDP protocol, right? We are using both protocol at transport layer, depends on our requirement. If I need fast communication, I will use TCP. If I need acknowledgement, I will use, if I need fast communication, I don't need acknowledgement, then I will use UDP. If I need acknowledgement, I need reliable communication, then I will use TCP. Like if I will talk about WhatsApp chat. So WhatsApp chat is kind of TCP communication because we are getting acknowledgement by double tick, right? So two protocols works at this layer, and which protocol will use, like HTTP is going to use which protocol, TCP or UDP, because HTTP have now two choice at transport layer. So it is predefined which protocol will use which service. At transport layer, when application layer will send data to transport layer have already knowledge that I need to use which protocol, TCP or UDP with this protocol. This is predefined in the application. Okay. Now, we will see more difference between TCP and UDP. For now, TCP is connection-oriented protocol and UDP is connection-less protocol. See, this is very important point, connection-oriented and connection-less. Let me make you understand this here. Guys, let's say here I have one computer and here this is my server PC. I have some data. I want to send this data from computer to this server. If I will use TCP, if I will use UDP, let me start from UDP. If I am using UDP, then simply my PC will forward this data to server, right? But if I will use TCP, if I am using TCP to send this data, TCP based communication. Then this machine will first stabilize a connection, stabilize the connection between PC and server, right? With the help of three messages. PC will send first SYN message, then server will send SYN plus ACK message, and then this PC will send ACK message, acknowledgement message. With the help of these three messages, both machine is going to stabilize a connection, a logical connection. This time benefit is what? This time server have already knowledge that PC is going to send me some data. I need to have some buffer, some space in buffer memory. I need to have some space in buffer memory. So this is benefit of TCP. So that's why we are saying TCP is connection oriented protocol and UDP is connection less protocol. Difference between connection oriented and connection less is very simple. Connection oriented protocol first establish a connection by sending three message, by exchanging three message, SYN message, SYN plus ACK message, and ACK message. In many book, you will see this picture of CCNA. Okay, so here SYN means what? SYN means simply hi. This computer is saying hi brother, server will say hi, and it is giving acknowledgement also. I receive your hi. It is sending their hi also and saying received your hi. It is giving acknowledgement also, and then finally computer is giving acknowledgement. I receive your hi. Okay, so TCP is connection oriented protocol, UDP is connection less protocol. You can learn these things in deep, right? But for now, this is enough for CCNA. TCP is connection oriented and UDP is connection less. Now some difference between TCP and UDP. So first difference is, you can see TCP is connection oriented protocol, means TCP is going to establish it is going to perform three-way handshake. That is called exchanging these three messages called three-way handshake. In my note also, you can see this diagram, three-way handshake. You can see three-way handshake. This is three-way handshake. First, this is sender machine. This is receiver machine. Sender machine is sending SYN message. Then receiver machine is sending SYN plus ACK message. And then sender machine is sending acknowledgement, and after that connection established, and now it is going to send data transfer. So first difference is TCP is connection oriented, UDP is connection less. Second is TCP, we can arrange receiving data in sequence. See, we have so in TCP so that we can arrange the receiving data in sequence, but that is not possible in case of UDP. Next difference is we can retransmit the data in TCP. Yes, we can retransmit the data in TCP, but that is not possible in case of UDP. Like let's say PC1 need to send some data to server. They have some packet 1, 2, 3, 4. This PC have sent 4 packet to this server, and on the link, let's say there are some congestion. Because of that congestion, one packet is dropped at link. So now this PC can send that single packet again in case of TCP. But in case of UDP, this machine need to send these all packets again. These all packets again. Retransmission is not possible in case of UDP. But in TCP, we can send only missing packet again, right? So retransmission is possible. Then it is reliable protocol. So we have acknowledgement also in TCP, but we don't have acknowledgement in UDP. That way we are saying it is reliable. Reliable means acknowledgement. Okay. Flow control can be achieved in TCP, but flow control can't be achieved in UDP. Windowing is used in TCP. Windowing is not used in UDP. Okay, this is not important for you. This is important again. TCP is slow because we have like acknowledgement here, three-way handshake in TCP. Then definitely TCP is slow as compared to UDP. right? Header length of TCP is 20 byte. So transport layer is going to add 20 byte extra information in case of TCP and 8 byte extra information in case of UDP. So if I will talk about the size of TCP header is 20 byte and size of UDP header is 8 byte. Fine. Then HTTP, HTTPS, Telnet, SSH. These are the protocol which uses TCP at transport layer, which uses TCP at transport layer. These are the protocol. These are only important protocol. Otherwise, there are many more. And DHCP, NTP, DNS, etc. are used UDP at transport layer at layer 4. So these protocol like DHCP, NTP, DNS, these protocol uses UDP. So any protocol, if need fast communication, reliability is required, then definitely they should use UDP. Fine. Then I have here described like what is the meaning of connection oriented, three-way handshake, sequence number, MTU, like retransmission. You can see here we have this information. Hello, this is packet 1, packet 2, packet 3, packet 4. I have 4 packets. I'm going to transmit these 4 packets. Sequence number of first packet is 1, sequence number of second packet is 2, sequence number of third packet is 3, sequence number of fourth packet is 4. And receiver machine have received only hello, how are. Means packet 1, packet 2, packet 3, 4 is missing. So in case of TCP, we can retransmit this packet only again, like U is missing. Fine. Now you can read these things. Now I am going to show you these all things practically. Network layer provide logical address like IP address. IP address is logical address. Okay. So network layer is responsible to provide IP addresses to packet. 1 second, guys. Okay. Now, no data link layer. At network layer, we have some more information like router and layer 3 switch works at this layer. The main function of router work at this layer. There are some protocols which works at this layer like IP protocol, EIGRP, OSPF, ICMP, and many more protocols are used at this layer, at network layer. And as a network engineer, you need to learn these all protocol like IP, EIGRP, OSPF, ICMP, BGP, right, and many more. There are many more network layer protocol also, right? We will see in upcoming day. Then data link layer. So data link layer provide physical address. Physical address means MAC address. Physical address means MAC address. At this layer, error detection is done. Error detection will also happen at this layer. Switch and bridge works at this layer. Switch and bridge works at this layer. Mainly switch works at this layer. This layer is responsible for forwarding data from one device to another device in a network only. Within network, if I have a network like this, R1, R2, let's say R3. These are router, and here I have one LAN. Here I have computer A, computer B, and here also I have computer A and computer B. So data link layer is responsible to make communication within network. Like this is different network and this is different network, right? Router connect network. So both are different network. Here data link is not going to forward data from one network to another network. Data link layer is responsible for inside communication within network. This is the only layer which header as well as a trailer added, where we are using both as well as trailer. We see this is practical, and protocols work at this layer: ARP, HTLC, etc. Right? ARP is very important for you. So ARP works at layer 2, and then physical layer. At this layer, hub, repeater, access point, transmission, media, and access at this layer. Like physical cable, simply you can say physical cable used at this layer. And physical layer is also responsible to detect the link, that link is working or not. Otherwise, let's say link is working. Machine is designing the data, it is generating the data, it is forwarding to each layer, but at the end physical layer is dropping the data because cable is not working fine. So he is going to detect the cable, physical layer. That physical layer will check cable is working or not. Then we have one term called PDU. PDU stands for protocol data unit. PDU is nothing but form of data, what we call data at each layer. Like at application layer, we call data to data. At presentation layer, we call data to data. At session layer, we call data to data. But at transport layer, we call data to segment. We call data to segment. Segment means what? Data plus TCP or UDP header. TCP or UDP header means transport layer header. Segment means what? Segment equals data plus TCP or UDP header. Then at network layer, we call data to packet. Packet means segment. Who will hand over segment to network layer? Transport layer. Segment plus IP header. IP header. Frame. At layer 2, we call data to frame. Frame means packet plus layer 2 header, data link layer header. And this is bits at physical layer. We call data to bits at physical layer. So if you want to see how TCP header look like, so you can see these are the information inside TCP header. One TCP header will carry these information: source port number, destination port number, sequence number, acknowledgement number, header length, reserve field is there. These are not important for you, but yes, these are the information inside TCP header. Flags are there, window size, checksum, urgent point, and then your actual data. So transport layer will add these all extra information with actual data. After that, we will call data to segment. And here you can read about each field also, like which field is responsible for which task. Source port, this is 16 bits value that specify the port number of sender who is going to send the data. Destination port, it is 16 bits value that specify the port number of receiver device. Sequence number, a number used by that put the data back in correct order or retransmits missing data during the process, called sequencing. Acknowledgement, header length, these are the extra information. After that, UDP header. UDP size is only 8 byte information. So you can see UDP will carry only these information: source port, destination port, header length, and checksum. After that, IP header. IP header will carry these all information: version, header length, priority, total length, identification field, flag, fragmented offset, TTL, time to leave, protocol, header checksum, source IP, destination IP, option field, and then data. So network layer will add these all information. Fine. Here also you can read about each field. will become application layer protocol. Just we need to revise it. Okay, application layers protocol. First is P. So HTTP protocol. See what you need to remember with protocol. Protocol port number. First thing is port number. What is the port number of that protocol? Like what is the port number of HTTP? This is how I learn this protocol. HTTP port number 80. Then which protocol it uses as transport layer? So it uses TCP at transport layer. It is used to access web page from the web server. It is not secure protocol. It is not secure protocol. Fine. Then HTTPS port number 443. It uses port number 443. It uses TCP at transport layer. That means what? These protocols are reliable. These protocols are reliable. First machine will establish a connection. It will establish a connection between sender and receiver. It is also used to access web page from the web server, and it is secure. Now let me perform one practical of HTTP and HTTPS. Let me show you how machine will generate it. So in my packet tracer, let's say here I have one computer. CDP, can I minimize this from the top? Is there anyone from CDP network?
Yeah, you can. You can.
How I can minimize it? I'm not able to see entire screen. Na? Okay, see, I have one PC here, and let's say I have one server also. Yes, one server that connect with each other. This is HTTP server. Let's say domain name is www.cdp.com. This is domain name of this server. IP address of this server is, let's say, 10.1.1.1.2, and IP address of this machine is 10.1.1.1. Fine. And then fine. So first of all, I am going to configure the IP addresses. Then I will enable HTTP service. I will configure this. I will host this application on this server. Let me assign IP address to PC. So to assign IP address to computers, you need to click on computer, then go to desktop and IP configuration. And here we can say IP address 10.1, subnet 255.255.255.0. Fine. Let me enter. Here now you can check the IP of this machine. Like in command, type in this command IP conf. So you can see IP address of this machine is 10.1.1.1. Fine. Let me assign one IP to this server also. 10.1.1.2.5.0. Okay, this is IP configuration. After that, on this server, I need to configure one services. So I will enter in services section. In services section, you will find HTTP. You will find this option HTTP, and HTTPS is also there or not. HTTPS is not there, but yes, HTTPS is also there. And by default, this on. You can see HTTP is also on. HTTPS is also on. Here we can configure the website. Like if anyone know the coding, so they can uh, they can design website here also. Okay, like you can see welcome to Cisco packet tracer. Here we can say welcome to CDP network, and let me save it. Okay, and now from this machine, if I will try to access this server, so let me open simulation mode to see the packets packet, HTTP. So yes, on this machine, first of all, I will open the browser. In the browser, I will type my IP address. I will type my IP address in the browser because here we don't have DNS. So we cannot access this website through domain name, right? We cannot access the server through domain name. In next practical, I will put DNS also. After that, we can access the server through DNS also. For now, I am going to access it through IP address. In the browser, I have typed this IP address 10.1.1.2 and let me hit enter. And you can see on this PC, we have now two packets. Now we have two packets, R packet, and second one is HTTP packet, a TCP packet, because HTTP uses what? TCP. As first establishes the connection. It establishes connection between sender and receiver. What this PC will do? This PC will send one SYN message. SYN message. Then server will send SYN plus ACK message. And then this PC will ACK message. And after that, this PC will send actual HTTP request. HTTPS request. Yes or no? So we are not going to discuss about ARP packet for now. ARP is used to resolve MAC address, IP address. Like you can see PC5. PC5 know what is the IP address of server, that is 10.1.1.2. We tell to this machine IP address of server is this one. But how this machine will get MAC address of this server? Because requirement of basic communication is source IP, destination IP, source MAC, destination MAC. So this machine need what? MAC address. This machine need MAC address. If I will check ARP table here, inside the ARP table, you can see there is no any entry. That means this machine don't know what is the MAC address of 10.1.1.2. And whenever machine don't know what is the MAC address of destination device, machine always generate ARP request. ARP request, we will discuss it in packet flow. Fine. So this machine have generate ARP request, and now it will send ARP request to this server, and server will generate ARP reply message. And now if you will check ARP table of this computer, after exchanging ARP request and reply message, you can see in the ARP table, we have one entry, IP address of server and MAC address of server. Now this machine know what is the MAC address of server, what is the IP address of server. Now this time this machine will generate TCP message. It will generate what? TCP message. Which type of message it is? It is TCP message. See, if I will open this message, inside this TCP message, we are able to see source IP. Source IP is 10.1.1.1. Destination IP is 10.1.1.2. Getting my point? Protocol field is also there. After that, this is TCP message. Actual TCP message. Sequence source port number. What is source port number in TCP message? 1025. As I told you, there are two types of port number, well known and unknown. So this is unknown port number. This PC is using port number from this range, from this random range. Where is port number? Here you can see 1025 is unknown port number. So this time PC is using same port number 1025. PC is using 1025 port number. Here you can see. And destination port is, what is destination? Destination is HTTP. So it is going to send this message to HTTP protocol. So destination port is 80. 80 is the well known port number of HTTP protocol. We are going to use HTTP here. And this is first packet, sequence number is 0, acknowledgement number is 0, and then there are some REST information. After that, this is actual data. So this is SYN message. And what this server will do, this server will generate SYN plus ACK message. If I will open this message, inside the TCP field, we are able to see acknowledgement number 1. Acknowledgement number 1. It is also sending SYN message with sequence number 0, and it is giving acknowledgement also on what acknowledgement number? Sequence number plus 1. So in SYN message, when PC have sent SYN message, sequence number was what? 1. So server is giving acknowledgement on acknowledgement number. Sequence number was 0. Sorry. In SYN message, sequence number was 0. Server generating acknowledgement on acknowledgement number 1. Sequence number plus 1. Fine. So that's why here acknowledgement number is 1. This is SYN plus ACK message. This is SYN plus ACK message. Source IP is SIM 10.1.1.2. Destination is IP address of PC, because server is sending this message. And finally, server will send what? Then server has plus ACK message. Which message? Acknowledgement message. From you can see here from www.cdp.com. And if you will check the browser now, in the browser, let me write again the address and 1.1.2. I think we time out. Just wait, let me do one thing. Yes, here we are able to open the website, and you can see this time this machine have generated one message. This is TCP message. First will send simple ACK message, then PC is going to send ACK message, and after that HTTP message, actual HTTP message. This is what HTTP request message. Here you can see in the bottom. This is HTTP request message. So this time PC is sending HTTP. Finally, PC is sending this message, HTTP request message. But before sending HTTP request message, both machine have built TCP connection. Both machine have built TCP connection with the help of 3 message: SYN, SYN plus ACK, and ACK. Right? This is HTTP request message. Rest thing at you can see inside the IP header, source IP, destination IP. Rest thing is same. Source port number is different. Destination port number is again same 80. Sequence number is 1. Acknowledgement number is 1. So acknowledgement bit is also 1 here. And now finally here we can see I have access of my website. Welcome CDP network. This is one a small lab of HTTP protocol. Now next application layer protocol is HTTPS. Like here we can do one thing in the browser. In the browser of this PC, I can put HTTPS. Here I am going to change it from HTTP to HTTPS. HTTPS. So you can see from S also, from HTTPS also, I am able to access this server, right? If you will see again with HTTPS, this is Which type of message it is? It is TCP SYN message. Every time first machine will generate SYN message, then SYN plus ACK, then ACK. And now PC is going to send actual HTTP message. If I will open this actual HTTP message, you can see destination port is 443. Destination port is, this is HTTPS packet, destination port is 443, source port is random port number 1032. It can pick any port number from that range. So this is HTTPS. Both are same. Difference, this is secure, HTTP is not secure. After that, telnet. Telnet uses port number 23 and it uses TCP at transport layer. It uses TCP at transport layer. It is used to access networking devices remotely. Let me perform one lab of telnet also here. For that, I am going to GIF because is not sufficient for this. Here, what I will do, I will charger लगा रही हूँ मैं भाई. Two router R1, R2. Let's say R2 is, I want to access R2 from R1. I want to access R2, router 2 from router number 1. See, लैपटॉप पे चार्जर करना दियो ना. इन है लैपटॉप. Let me turn on the device. Just wait. Okay, so here my IP address is, let's say, 12.1.1.1. And here this side my IP address is 12.1.1. Let me write here 12.1.1.2. Here IP address 12.1, here IP address is 12.2. I will access both router 1, router 2. First of all, let me configure IP addresses on both router. I have access, config T, interface, fast Ethernet 0/0, say no set, and IP address is 12.1.1.1, 255.255.255.255.0, exit. This is R1. We can verify the IP, so IP interface exclude, unassigned. So IP interface brief exclude unassigned. We can see the IP address on fast Ethernet 0/0 is 12.1.1.1, and this interface is up. Everything is fine. Interface is okay. This is up. Line protocol is also up. On router number 2 also, let me configure the IP interface fast Ethernet 0/0, say no set, and IP address 12.1.1.2, 255.255.255.0, exit. And on PC number 2, sorry, router number 2, I will enable telnet. First of all, I will verify the connectivity between router 1 and router 2. So from router 1, I am going to ping router 2, ping 12.1.1.2. So you can see I'm able to ping 12.1.1.2. That means connectivity is there. I'm going to enable telnet on router number 2, and then I will access router 2 from router number 1, and I will capture the link between router 1 router 2 so that we can see all packets. Between router 1 and router 2. Before that, here let me configure line VTY 04. This is telnet configuration. We will discuss it later. Cisco 123 is my password and say login. Fine. And enable password also, let me configure enable password also Cisco 123. Done. Now from router number 1, I can type this command telnet 12.1.1.2. But before that, I will capture the link. So let me start capturing between router 1 and router 2. So you can see these are packets on this link, right? These are packet on this link. First, on router number 1, I have typed this command telnet and then IP address of machine. Router 2, hit enter. If I will hit enter over here, it is asking for password. It is asking for password. Cisco 123 is my password. And now you can see I have access of R2. And here in the capturing, you can see there are many traffic of telnet. This is telnet data, right? And before telnet data, we have 3 messages: seen message, seen message, and ACK message. Why? Because telnet uses TCP protocol. Just 1 second, guys. Yeah. So telnet uses TCP. Before that, first both devices have stabilized a connection, TCP connection. Both have built TCP connection with the help of 3-way handshake. And after that, 12.1.1 means send one telnet message to 12.1.1.2. 12.1.1.2. I will open this message. Let me show you this message. And you can see this is my actual telnet data. This is transport layer. At transport layer, it is using TCP protocol and IP network layer, IP protocol, then data link layer, Ethernet header, and then physical layer wire. 66 bytes on wire. Fine. So if you will open telnet message, see, this is not important for you. As I told you, this is coding, right? Important is this layer, transport layer. Transport layer, inside the transport layer, port number from the unknown port number range. Destination port number is 23. 23 port number is for 23 port number is for telnet. So when router 2 will receive this data at transport layer, it will check this field, destination port number. At transport layer, it will check destination port number. Destination port number is telnet. Then it will check that telnet service is enabled or disabled here. So yes, telnet service is enabled. Then hand over actual telnet message to telnet protocol. Actual message to telnet protocol. So this exactly same here also, only we are able to see destination port is 23, right? After that, in the first scene message, if you will open first scene message, you can see sequence number is 0. Sequence number is 0 and next sequence number is 1 and acknowledgement number is 0. And in the scene plus ACK message, which router 2 is sending to router 1, here you can see source port, destination port is same like previous, and sequence is 0 and acknowledgement number is what? 1. It is giving acknowledgement also, and their sequence number is 1, and their sequence number is 0, and their next sequence number is 1. Okay, so this are telnet. These are telnet data. Every time you will see whenever we will send any data of telnet to router 2, source port will be the random and destination port will be 23. Whenever router 2 will send any message of telnet to router 1, source port will be 20 and destination port will be the random. And now you can check table also. Like if you want to check connection, TCP connection between so let me write exit here and so TCP. Now you can see here this time there is no end connection on this router because I printed the telnet. Now if I will again this 1.1.1.2 and password is Cisco 123 and Cisco 123 password was different. Okay, Cisco 123. Yes, enable and Cisco 123. And now if we will check, so TCP brief. This time you can see there is one connection. State is established. 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 12.1.2 is using what number? 23. And 12.1.1.1 is using what port number? This random port number. Right? There are two connections. One is this one also, but here time waiting is right. So this one is latest one. If I will exit, if I will terminate the connection, and if I will check, so TCP, you can see TCP table is now empty. TCP table is now empty. Next protocol, SSH. SSH is also like telnet, but it is secure and telnet is unsecure. Then file transfer protocol uses port number 20 and 21. Use TCP at transport layer. It is used for file complex. Then TFTP and P, we don't need to perform lab of this protocol. DHCP. DHCP is important and it uses two port numbers, 67 and 68. So DHCP client machine uses DHCP client machine uses UP port number 8, uses 7. And what we can do, we can perform on lab of DHCP. Let me enable DHCP service on router number 2. Config T, IP DHCP pool CCNA and router. Here we can run this command. See, you can define DNS server IP address here, default router IP address here, domain name that is, and this information like default router and DNS. Let's say 8.8.8.8 and IP DHCP exclude address. If you want to exclude like any address, here you can run this command, exclude address, and IP DHCP pool CCNA, and here we need to run network command also. Network 10.1.1.0 mask is 255.255.255.0. So from this network, this will provide PS. Now this machine is acting as DHCP. This machine is acting as DHCP. Okay, let me do one thing here. Interface fast Ethernet 0/0. I'm going to change the IP address. IP address is 10.1.1. I have exclude one IP address, that is 10.1.1.2. So let's say 2 is here. 255.255.255.0. Now router 1, let's say need one IP address. On router number 1, I am going to remove the IP. Okay, I have assigned this on router number 1. So on router number 2, I am going to remove IP configuration. Interface fast 0/0. Say no IP address. I remove IP configuration. Here is the capturing. Okay, here is the capturing. From router number 2, I can say IP address DHCP. I am requesting for IP address to DHCP and the capturing. Let me check. It have been RS first to 10.1.1.1. That means this machine have one IP address, that is 10.1.1.1. This machine have got this IP address 10.1.1.1 from DHCP server, this submit mask, right? And if you will check running configuration of this router, so run inside the running configuration, you can see this router have got default gateway IP address also. IP default gateway should be somewhere. Say include default. Okay, we are not able to see like this, but yes, this machine have got DNS server IP address also, IP address on their interface also. So IP interface brief exclude unassigned. So you can see how method is DHCP. On router number 1, method is so IP interface brief exclude unassigned. Here method is mail. On router number 2, method is DHCP. So here don't know why we are not able to see some message. Yes, we are able to see some messages of DHCP. Like this is first message of DHCP. Discover message. Guys, DHCP work on DORA process. DHCP work on DORA process. DORA means DORA. DORA. Discover, offer, request, and acknowledgement. Discover, offer, request, and acknowledgement. See, first machine have sent one discover message. Let's say I have one computer here. This is the server. This computer need IP address from DHCP server. So this machine will send an all message. Sorry, discover message first. Discover message. Discover who is DHCP server, because this machine don't have any identity till now. This machine don't have IP address. So they need IP address from DHCP server. So this machine will send first discover message. After that, this server will send this message, offer message. DORA. Second message is offer message. Who is going to offer? DHCP server. DHCP server will offer one IP address to this client machine through offer message. Let's say DHCP is offering 10.1.1.1. Then again, this client machine will send one message, that is request message. Request message. Can I assign the IP address to my interface? So client machine will send request message. And finally, server will send acknowledgement message. Acknowledgement message that yes, you can assign this IP address to your interface. This is how DHCP work. So DHCP work on DORA process. We have 4 type of messages in DHCP: discover, offer, request, and acknowledgement. Client machine will send discover message, then server machine will send offer message, then the client machine will send request message, then server will send acknowledgement. So we have these four types of message in DSCP. So DSCP is an application layer protocol which uses UDP, which uses UDP. Now, if you will open this discover message, you can see this discover message is guys broadcast at layer 2 also, at data link layer also, and at network layer also. If I will open it, and you can see this is actual DSCP message. After that, this is transport layer. At transport layer, we are using UDP, user datagram protocol, because DSCP uses UDP. Source port number is 68. As I told you, client will use 68 port number and server will use 67 port number. So destination port is 67. Source IP, we don't have any IP address till now. So source IP address is 0.0.0.0. Destination IP is 255.255.255.255 broadcast. Source MAC is the MAC address of sender machine, and destination MAC is again broadcast, right? After that, if you open next message, that is offer message. Inside the offer message also, you can see source port is 67. 67 is port number of DSCP server. So source port is 67, destination port is 68. Source IP is IP address of DSCP server, and destination is broadcast. Again, destination is broadcast. And if you will open this DSCP message, so you can see inside this DSCP message, it is offering one IP address, that is 10.1.1.1. DSCP server is offering this IP address to client machine. And finally, request message. Then we can see the request message. Inside the request message also, source IP is 0.0.0.0. Destination is 255.255.255.255. Source port is 68. Destination port is 67. Source MAC is the MAC address of client. Destination MAC is broadcast. Still, destination MAC is broadcast. Okay. And after that, acknowledgement message. Who will send acknowledgement message? 10.2 means DSCP server. DSCP server will send acknowledgement message. So acknowledgement is also broadcast. That means we have seen all messages of DSCP are broadcast. All messages of DSCP is broadcast. Clear? Now, DSCP work on DORA process. We have 4 messages in DSCP. It uses port number 67, 68. It uses TCP, UDP at transport layer. How much is this matter? Okay. So these are application layer protocol. Okay. Now next application layer protocol is DNS, domain name system. DNS uses port number 53. It uses both again TCP and UDP at transport layer. It is used to resolve fully qualified domain name into IP addresses. Like guys, see, there are millions of sites in the world. It is not possible to remember the IP addresses of website. IP addresses of website. Remembering name is easier than remembering number. So that's why we come up with DNS. That's why we come up with DNS. So DNS is actually responsible to resolve domain name from IP address. Like if I will show you here, let's say this machine now I can access this cdp.com from this PC with what? With this IP address. But I can access this server through domain name also. Here I can configure the DNS server. Go to services, and then you can see we have one DNS option here, DNS. And by default, the service is off. I can turn it on, and then I can put one domain name, www.cdp.com, and then I can tell IP address of this website, that is 10.1.1.2, and I can add this entry. Now inside the DNS cache, you can see we have one entry. Domain name is www.cdp.com, and IP address is this one. Now whenever someone will ask to this server that what is the IP address of www.cdp.com, it can share this IP address. So now on this PC, I can access, let me check, can I access my website through domain name www.cdp.com? Still, I am not able to see host name unresolved. This machine is not able to resolve this domain name, but you can access through IP address 10.1.1.1.2. Yes, I am able to access through IP address, but I am not able to access through www.cdp network, cdp.com. Through domain name, I am not able to resolve. Why? Because this machine don't know what is the IP address of DNS. So I have to tell to this machine, see, I can tell to this machine, your DNS server IP address is 10.1.1.2, right? And now let me try again. Now you can see, this time I have tell to my machine, DNS is 10.1.1.2. So if I will type www.cdp.com, and let me open simulation mode also, and let me hit enter here. Now you can see, this is which type of message it is. This is ARP message, okay, and this is DNS message. This is DNS message. Through this message, this PC is going to ask to whom? 10.1.1.2. What is the IP address of this domain name? What is the IP address of www.cdp.com? Getting my point? It will first forward the ARP packet. It will receive ARP reply. Then it will send DNS request message. It will receive DNS reply. And after that, it will send actual HTTP message. This is TCP message. TCP, SYN message, SYN plus ACK message, and after that HTTPS message. This is how, and you can check now, you are able to access the website through domain name also. Okay. So these are application layer protocols. We have, these are important, right? These are important protocol. This is all about OSI layers. We discussed the function working of all layers in OSI model. We discussed also application layer protocols. We seen the practicals of TCP based protocol and UDP based practical. Now, if you have any question, please ask in chat. Yes, CDP, can I stop my screen sharing?
Yeah, sure.
Please check the chat. And if anyone have question, please let me know, guys, in chat. Any question from OSI layers, because it is very, very, very important. OSI layer is very important for network engineer. Even you are network engineer, you are planning to become network engineer, you are planning to attend CCNA exam, you are planning to, attend any Cisco certification or any other vendor certification also. OSI layer is very important. Yes, you will get this recording also, this PDF also. Thank you. You can break if you forget the telnet password, no problem. You can forget the password, right? You have to learn it, like how to break the password, how to recover the password, how to change the password on router. You need to learn it. Can you please explain DSCP in brief? Okay, I can discuss DSCP in brief, but not in this class. We will let you know next class Next class date in WhatsApp group. Yeah, sure. What is difference between HTTP and HTTPS? HTTP is not secure. HTTPS is secure. In HTTP, data will travel in plain text. In HTTPS, data will travel in encrypted format. No, OSI have 7 layers. How to configure home lab? After learning CCNA complete syllabus, you can design, lab. What is the best simulation for CCN? GNS3 and EVNG is the best software for CCNP. For CCNA, GNS3 and Packet Tracer both are good. What is Cisco Packet Tracer? Cisco Packet Tracer is simulation software where you can perform lab virtually. Thanks a lot. It was a nice lesson. Thank you, brother. This session is free. Like, if you want to learn DHCP in detail, definitely you have to enroll for the advanced course for the detailed explanation. In paid course, you will learn these all things in detail, like DNS, DHCP. We will have separate session on these protocols. One session for one protocol. You are some commands at Cisco and GNS3. Please share the basic commands by mentioning their function. Okay, I can do that. I can do this. I will try to share some basic commands of router and switches. Routers and switches. At the last, I will share around 500 interview questions with you. Yeah, yeah, that is enough for exam, also for interview perspective. Not for exam. For exam, you have to prepare dumb paper. You have to solve dumb. But for interview, that is enough. No, we will have more session. We'll inform you in WhatsApp group. Yeah, every Saturday and Sunday, but this is festival time. Because of that, tomorrow is off. Otherwise, maybe from the next week or after next week, means in next month, we will have session on Saturday and Sunday. If you can also provide us with some dumb paper here. Telnet is used to access networking devices remotely. Telnet is used to access remote networking devices remotely. SSH, yes, same purpose, but SSH is again secure like HTTPS, and Telnet is not secure. Yeah, I will share some basic commands, right, of router and switches in WhatsApp group. Network layer is responsible to provide logical addressing to the data. Logical addressing means IP addressing to the data. Okay, guys, then bye bye. See you in next class. Thanks for joining. Thank you, CDP.